Dear students, welcome back to Operating System lecture video sessions. In this lecture video, we are going to discuss about deadlocks, which is of Unit 3, Chapter 7 contents. This is Dr. K. Praveen Kumar, Assistant Professor, Department of Information Technology. Welcome back to our Operating System lecture videos. Objectives of this chapter are these are the different concepts we are going to discuss: system model, deadlock characterization, methods for deadlock handling, deadlock prevention, deadlock avoidance, deadlock detection, recovery from deadlocks. So these are the chapter objectives: to develop a description of deadlocks, which prevents set of concurrent process from completing their task, and to present a number of different methods for preventing or avoiding deadlocks in computer systems. So how to prevent the deadlock, how to avoid the deadlock, we are going to learn in this session. Lecture outcome: upon completion of this lecture video, student will be able to define deadlock and identify what is resource, what is process, and identify the system model and deadlock characterization, how to handle these deadlocks, how to prevent the deadlock and avoid the deadlocks, and how to detect the deadlock before it arises, and how to recover the system from the deadlock. So these are the lecture outcomes. First one, before going to deadlock, we have to know what is system model. What is system model? System consists of resources. See, your system will contain different resources called R1, R2, R3, and so on, Rn. So what are these resources? Resources may be whatever it may be, which a process can finish the work, which resource will help that. For example, CPU cycles, memory space. If I want to do some work, I need some space, right? So that is memory space. Memory space is a resource. IO devices, for example, if I want to print some pages, then I need printer. Printer is a resource which is allocated by your operating system. Sometimes a scanner, when I want to insert some pages into PDF and I want to digitize it in scanner. Then even when you are playing some games, joysticks, one of the joysticks also called as, you can say it as a resource. Right? So there are several types of resources in your operating system. So each resource type RA has WI instances. Students, this you have to remember. RI has different number of instances. For example, if this is a printer, my system may be connected with different number of printers, P1, P2, P3, P4, 4 kinds of printers. If my resource is a memory space can be whatever it may be. It's an hard disk, or it's an CD, it's an DVD, or it's an pen drive, whatever it may be. So each and every resources have different number of instances that you have to remember. So how a process can utilize this resource? Remember, these resources can be utilized by your processes. Okay. So how it is going to use? A process can request for a resource. For example, if it needs some memory, so the process will request, I need so and so resource type of n number of instances. Like that, it is going to request. That will be allocated by the operating system. Whenever it is allocated, process will utilize that resource, that is, it will utilize that use that resource, and it complete the task, and after completion of its task, it will release that resources. It will release the resource so that it can be, that resource can be utilized by the another process. So this is the generally concept will go on. So whenever a process needs some resource, it will request and it will use it. After completion of it uses, it will release it, right? So this is generally system model will consist of. Right. Before entering into the deadlock, we have to know what is deadlock. So a deadlock is a situation in which two computers are two computer programs, that you can also call it as two processes sharing the same resources are effectively preventing each other from accessing in the resource, then resulting in both the programs using that function will not work. If you see this diagram here, resource, this is process 1, this is process 1, and process 1 is having this resource 1. Process 1 is already having this resource 1, right? And it is requesting for resource 2. Process 1 is waiting for and requesting for resource 2, which is already assigned to process 2. This resource 2 is already assigned to process 2, and this process 2 is waiting for resource 1, and this is which is already held by your process 1. So process 1 cannot release this resource 1 until this it get the resource 2, and process 2 will not release this resource 2 until it get resource 1. So this is a cycle, right? So in such cases, we call it as a deadlock. Right? Hope you are clear with the deadlock definition. Right. So deadlock will have certain characterization. So what are the characterizations of deadlock? So first one, mutual execution. It will be having 4 conditions. If any condition is holding simultaneously, then we call it as deadlock. First one is mutual execution. Mutual execution, only one process at a time can use a resource. So this is the first proper characterization of deadlock is mutual execution. Only one process at a time can use a resource. So second process cannot be used other resources. Hold and wait. A process holding at least one resource is waiting to acquire additional resource held by other process. So this is also one of the deadlock characterization. A process is holding, it is already holding one resource and it is requesting for another resource which is already held by the another process, right? So this leads to the deadlock. No preemption. So a resource can be released only voluntarily by the process holding it after that process has completed its task. So then this also one of the characterization of deadlock. Circular wait. So if there exists several processes of waiting each process. For example, P0 is waiting for a process which is held by the process 1, and process 1 is holding requesting a process which is held by process 2, and process 3 is requesting for a resource which is held by the process 3. And if process 3 is waiting for a resource which is held by or held by process 1, process not. So when there exists a cycle, then we can say that there exists a deadlock. So these are the characteristics of deadlock. Right. So to explain these deadlocks in a more efficient way, we have one way, that is resource allocation graph. If with this resource allocation graph, you can depict the number of resources and the processes, how many processes are holding how many resources and how many processes are requesting how many resources. That can be depicted with help of RAG, that is resource allocation graph. So there is a set of vertices and set of edges. So vertices is partitioned into two types. One is process and another one is resource. Process P1 to Pn, set of consisting of all process in the system. A resource R1 to Rn, set consisting of all resource type in the system. So there are two types of edges. One is request edge, directed from whenever a process is requesting one resource, then it will be like this. Process 1 is requesting R4, right? Second one is assignment edge. If a resource is already allocated to a particular process, then it will be like this. R4 tends to P1. If this resource is already allocated to P1, then this will be like this. Right. Resource allocation graph. First one, this circle is a process. Process will be denoted with the help of a circle. And the resource types, these are the resource type. So you have to mention in a brackets. If it is having a instances, you have to write like this. If it is having two instances, only two boxes inside your resource. And if a process is requesting a resource, then you can say like this. If one resource is already assigned to a process, then that particular resource instance will be given like this. So this is another type. So this is all about the basics of deadlocks. In the next class, we will discuss more about resource allocation graphs. Thank you.